Hi everyone, Professor Christina Sober from Cal State Long Beach speaking here. And in this video, we are going to look at an experiment involving a penny and a dime and look at this in terms of probability. So, an example of an experiment that we're going to do involving a penny and a dime. First off, an experiment is what you're observing or doing with the objects. And so the experiment we might have is the experiment of uh, flipping or tossing in the air a penny followed by a dime and recording the outcomes of the faces of each coin. So because we're talking about the experiment with the penny being flipped first, because we said followed by the dime, so the penny happens first and the dime happens second. So a couple of people might write down like it's penny and then dime, like a P and then a D, or they might make a little chart where they have penny and then they have dime and they'll write down the outcome. We'll do a combination of things and then also use precise notation. An outcome of this experiment, well, if we use that chart we talked about, penny first and then dime second, the penny could be ahead. I'll write H for head, and the dime could be ahead. That's one outcome of this experiment. And again, let's just highlight this for clarity. An outcome could be head followed by head. Another outcome that could happen is I get a head first for the penny and the dime actually being a tails, a T for tails. Or the penny could be tails and the dime could be head. And lastly, the penny could be tail and the dime could be tail. We actually just wrote out the entire sample space for this experiment when you write out all of the possible outcomes. This is also known as all or total possible outcomes. Using precise notation, you would draw like a swirly brace, and with or without parentheses, you could write HH for heads followed by heads, HT for heads for the penny followed by tails for the dime, TH for the penny being tail and the dime being head, or TT when they're both tails. Another way, if you wanted to write the sample space, you could have written H, comma, H like this with parentheses around it. But then you get a lot of parentheses going on. And if you can simplify your notation so that you still get the point across of the different outcomes without all of these additional parentheses, that's totally fine. I will typically use the shorthand notation for the sample space of this experiment, where our experiment is flipping a penny followed by a dime and recording the outcomes or the faces of each coin. One other thing that might be good to know is how many items that there are. And there's 4 total possible outcomes. Some people will write the size of the sample space is equal to 4, where the sample space again is all total possible outcomes. I'll write SS for sample space as shorthand if I ever do write that out. All right, from here, A specific event for this experiment is both coins flip to the same face. Well, for this specific experiment, I'm going to call it experiment A, or event A, excuse me. This is event A. And so if I wanted to find the probability of event A, you could write probability of event A with this notation, or you could just write probability of event A with this notation. You could also just write the probability of both coins same face, or just same. That's all different great notations. That's a specific experiment event in this scenario. It's probabilistic because we don't really control it. Anything is possible. Uh, this could or could not happen. There is some flexibility in why it's a probabilistic situation. So uh, we can repeat the experiment and have variability of results. Would be why it's probabilistic. But really, almost anything is a probabilistic situation if there's some wiggle room of whether or not it's possible to happen. You don't know what's going to actually happen when you do flip two coins. And this is something that you'll do in your groups, is do some simulations of experiments. Now, we found the notation in C up here to find the probability of the event you described in part C. So we want to find the probability that both sides, or both of the same coin face. We had this be our probability event A. Something that's really helpful is to write out the sample space for A. And the only way that happens, well, let's take a look at our sample space earlier. We had head, 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 tail, tail, head, and tail, tail. The only two that match are HH and TT. That's why it's really helpful to write out the sample space. We could have heads and heads, both penny and dime are heads, or we could have tails and tails. And so both coins are tails. The probability of an event is actually the size of its sample space divided by the size of all of the outcomes, so the total sample space. And I'm using a lot of words intertwined. What I mean here is on the numerator for the probability, which I am highlighting in red, you write how many items actually give you what you want. And we could have HH and we could have TT. So that's going to be 2, the size of the event A of getting both coins to match is 2, divided by how many elements are in your total possible outcomes or in your total sample space. We found to be 4 already earlier because we wrote everything down. That's going to be 2/4. And you could also reduce this to be 1/2. That's fine as well. So you would just find it by looking at the total sample space and seeing what you want to have happen in the event that we're looking at. Let's look at another example. You observe the color of a traffic signal when a vehicle approaches the traffic signal. There are 3 colors. The signal is on green for 20 seconds, yellow for 5 seconds, and red for 30 seconds before it cycles through again. The traffic signal is not synchronized to other signals, and the arrival time of the vehicles is random. This last sentence here that the traffic signal is not synchronized to other signals and the arrival time of the vehicles is random, sorry, is them trying to tell us that this is a probabilistic situation. So because there's no connection to anything else, we are good to go. We can use our probability skills. And so your experiment is the first sentence that they gave us. You observe the color of a traffic signal when a vehicle approaches the traffic signal. This is our experiment. What are you doing to collect some data? We need to know specifically when we write down the color of the traffic signal. And our way of measuring is anytime any vehicle comes to the light, we want to take a look at it. What color is that light? You could do this every minute, every second, every 5 minutes, every hour, um, every time you take a drink of water for some reason. There's many different ways that you can say, okay, when this action happens, this is when we're going to record our information. But for this specific experiment, we chose to look when the vehicles approach the light. There's some simplifications we're doing here. What happens when there's like two vehicles at the light? We record that. But for just simplicity's sake, we're going to say that at this particular traffic signal, only one car can come up to the light at a time to just make it easy for us. So, with that as our experiment, we want to look at the outcomes, and they told us this information as well, that there are three colors. It could be green, yellow, or red. So different outcomes. I'm going to look at the entire sample space. We could have a green light. We could have a yellow light. And we could have a red light. I know that the question is worded in a way that feels like just putting one outcome is totally fine, and it is, but I think it's so much more useful in the future to just list out your sample space. And what I'm doing is I'm listing out the discrete number of outcomes in that sample space, though you could word it in other ways where you don't list everything out. And it just depends on what your outcomes are. I personally think that if you have the opportunity to write every single bit out, it's easier to have it all visual. Another way of writing the sample space, you could just write the words green, yellow, and red. You could also put just a G, a Y, and an R. But I think if you do this last option, you should also provide a key, like, G equals green, and Y equals yellow, and R equals red. I know it might seem silly, but it's really helpful to be as precise and as clear as possible for anybody who's looking at your work. I'll probably stop at the midpoint here, kind of the middle ground of I'm not just putting a letter, but I am getting rid of the word light because in this context, we know what the colors are associated to. Most people have seen a traffic signal. Now for part C, describe a specific event for this experiment. Well, an event is something that could happen in your experiment. And I want to record when I don't get red. So a vehicle, oops, I spelled vehicle wrong. Let's fix that. Vehicle approaches the traffic signal and the traffic signal is not red. We might write that then we're trying to find a probability of a not red light. I'm going to just say this event is getting not red. For part D, how will we find the probability of this chance event you described in part C? I'm going to show you the incorrect way to calculate this first, then we'll do the correct way. So I'm going to write in big black letters that this is the common mistakes students make. So watch out for this. They'll try to find the probability of not red, and they'll say, okay, well, the probability of not red is the probability of green or yellow. And we're all good so far. This is correct. But what they'll say is, okay, our options are green, yellow, and red. So green and yellow, the number of ways you could get green or yellow, well, that's two different ways. And then they'll look at the probability of the sample space of the traffic signal color. So they'll say, it's 2/3. But this is a mistake. Oh no, it's not going to be 2/3. We want to look a little bit more precisely. So we were good up to this point, and this was okay too, but that 2/3 is not correct. Let's go back to pink and try to find the probability of not red. I really enjoyed the probability of green or yellow written using or notation. There's actually the probability addition rule that we have going on here, and it's the probability of getting a green light, or means to add in probability land, plus the probability of getting a yellow light, minus the probability of getting a green and a yellow light. We'll take a moment here. Can I have a green and a yellow light? No, that's not possible. So the last one that we're minusing here is just 0. So we have to find the probability of getting green and the probability of getting yellow. Well, when we did the penny and dime example, we just took for granted that we just got, two ways to get the same coin face out of 4 total ways. But what was the subtlety here is that all of these different outcomes for the coin flip were equally likely to occur. That is not the case for the traffic signal. There's really important information that I'll highlight in just a moment. The signal is on green for 20 seconds, yellow for 5 seconds, and red for 30 seconds. Those 3 numbers there are all of our possible time signatures. So we actually have to look at the probability of time for each one. Well, I'm going to just rewrite that information on the side here. I'll use blue. It's going to be green for 20 seconds, yellow for 5 seconds, and red for 30 seconds. Let's just verify that what we wrote down in blue matches what we had highlighted in yellow. And it does. It's always a nice idea to go back and check. With that in mind, the number of seconds that give you green is 20 seconds. The number of seconds that give you yellow is 5 seconds. The denominator for any probability is always just the total possible outcomes. And so how that translates in this example is the total amount of time Well, that's going to be 20 seconds plus 5 seconds plus 30 seconds for each of these green and yellow light options. 20 plus 5 plus 30 is 55. So we'll get 20 over 55 plus 5 over 55. And we don't need that minus 0 anymore because it's impossible to get the probability of yellow and green. So it's just 0. It's gone away. So now that we have this, we're going to get 20 plus 5 divided by 55 is 25 55ths. And that's the probability of not red. Let me add in a page here and look at this problem in another way. So we just talked about looking at the probability of not red as probability of green or yellow. There's another way that we could calculate this. The probability of not red is the same as 1 minus the probability of red. Now this comes from the fact that the 1 represents all of the possible outcomes in the sample space. If we take away the red options, all we're left in is the not red options. If you're still confused about how the probability of red is equal to 1 minus not red, let's meet during our free work days or during student hours, and I'm happy to go over that in more detail. That being said, let's draw a little squiggly line here to break that up, and I apologize if you can hear the motorcycle outside of my apartment. We'll do 1 minus, well, let's just write this out in words again. The numerator for probability of red is the time the light is red, and the denominator is all of the time for one like sequence of the light. And when I say light, I mean the traffic signal. So we have 1 minus the time the light is red. I see above, red was for 30 seconds. Out of all of the time possible, well, that was the 20 seconds for green, or the 5 seconds for yellow, or the 30 seconds for red. And that's the only color options we have going on. So we're going to get 1 minus 30 over 55. 1 is the same as 55 55ths minus 30 55ths, which is equal to 25 55ths. The 20 seconds for yellow and 20 seconds for green and the 5 seconds for yellow. And in fact, they both match. I hope that this video has served as a nice way to think about experiments and outcomes and calculating probability. If you have any questions at all, please reach out. I'm happy to help as soon as I can. Thank you so much for watching. I'll see you soon. Thanks. Bye.